Just as we are said to orbit the sun and rotate on our fixed axis, we must also consider the 137 miles per second in which the sun commutes its journey around the center of the galaxy. But we can't stop there. We also have to remember and address the 1.3 million miles per hour the galaxy moves through the universe. Our entire solar system is located about halfway to the outside edge of the Milky Way galaxy in an outer spiral arm called the Orion Arm or Orion Spur. Provided the current model, our solar system from outside would possess a trail that would resemble a spiraling helix, much like a strand of DNA. But how could that be possible with what we observe? The moon, the biggest and brightest object in the night sky, orbiting about 238,900 miles away from Earth and measuring in about 1/4 its size in diameter, orbits the Earth at a speed of 2,288 miles per hour, and is, as we all know, directly connected to the tides and many biological functions of most, if not all, life on Earth. What I would like you to ponder on is, after all this motion and time, considering the laws of thermodynamics, entropy, centripetal, centrifugal, inertial, gravitational, and electromagnetic forces, how is it possible the luminaries overhead continuously and without fail realign themselves so precisely to somehow allow for these drastically different in size and distance two-dimensional circles to eclipse one another? We not only experience a solar eclipse, which one would assume would be an improbability or rarity to ever occur, but somehow a solar eclipse occurs twice a year. Approximately every 18 months or so, a total solar eclipse is visible somewhere on Earth, which makes 2 total eclipses every 3 years. What is an eclipse? An eclipse is a powerful interaction between the Earth, the Moon, and the Sun. We usually have 4 to 6 eclipses a year, and they take place on new moons or full moons and are 3 times more powerful than a regular new moon or full moon. Eclipses always arrive in pairs, usually with one followed by the other. Once they visit, they tend to appear again about every 6 months on average. What is a solar eclipse? A solar eclipse appears when the moon stands between the sun and the earth, cutting off the light of the sun from our perspective. A solar eclipse is a powerful lunation that takes place on a new moon. It is 3 times more potent than a new moon and often brings exciting new beginnings, fresh starts, and new chapters. What is a lunar eclipse? A lunar eclipse arrives when the Earth stands between the moon and the sun. This cuts off the light of the sun from the moon. During these events, the moon may become red, orange, brown, or disappear entirely. A lunar eclipse is a very intense lunation that takes place on a full moon. It is 3 times more potent than a regular full moon and often brings major endings, turning points, and revelations and culminations. When trying to calculate the circumference of a circle, the mathematical formula to do so is pi 3.14 multiplied by the diameter, which we have the radius 93.2 million miles, multiplied by 2. Provided we are 93 million miles away from the sun, applying the above equation, our orbit is roughly 585.6 million miles. Completed within 365.256 days would put us at a speed again of 67,000 miles per hour. To understand that we can view not only precise solar eclipses but a continuous lunar phase, plus regularly and precisely timed lunar eclipses is even more amazing. To witness 2 objects so colossally different in size and distance be the precise size and distance relationship to one another, 1/400th to be exact, to even allow for an eclipse from our perspective, but to continue seeing it is in my opinion absolutely mind-blowing. However, To witness the shadow of the Earth also match the diameter of the moon during a lunar eclipse is where things begin to become very odd. When studying further, you will realize that somehow, after all the motions listed, these mysterious objects in the sky will not only continuously align with one another, but the moon has, by some miracle, caught itself in orbit at the exact distance for the shadow of Earth to completely cover it, but somehow at the exact speed, distance, circumference, and rotation needed to provide us with a view of only one face, hence the dark side of the moon. Should there even be a discrepancy of a few miles per hour caused by a gradual decrease in the speed of its rotation, the moon should, in theory, rotate from our perspective even a few degrees, but this is not what we see. They do not rise or fall from their paths, nor do they deviate in speed. I ask again, how could this much perfection be possible? These may have been the very same thought processes of those of the ancient world when creating their monolithic structures, priceless art, or precise astrological calendars. Is it just a coincidence that the mathematical symbol for infinity is very similar to the analemma depicted on the back of the imperial globe? The analemma, or vertical sunray indicator, is the diagram of the large figure 8 in the Pacific Ocean. The analemma is not shown on some globes. For every day in the year, the analemma show the latitude where the sun's rays are vertical and the equation of time, which tells whether the sun is ahead or behind. For every day of the year, the analemma show the latitude where the sun's rays are vertical and the equation of time, which tells whether the clock is ahead or behind the sun. The analemma extends between the points 23.5 north and 23.5 south only, or between the Tropics of Capricorn and the Tropic of Cancer. The region between these lines is known as the tropics. The sun's rays do not fall vertically outside the tropics. How much water is in the oceans? It is hard to imagine, but about 97% of the Earth's water can be found in our ocean. Of the tiny percentage that's not in the ocean, about 2% is frozen up in glaciers and ice caps. Less than 1% of all the water on Earth is fresh. A tiny fraction of water exists as water vapor in our atmosphere. According to the U.S. Geological Survey, there are over 1,386,000,000 cubic kilometers of water on the planet. A cubic mile is the volume of a cube measuring 1 mile on each side. Of this vast volume of water, the NOAA's National Geophysical Data Center estimates that 1,335,000,000 cubic kilometers is in the ocean. That's enough water to fill about that number gallon-sized milk containers. The ocean covers more than 70% of the surface of our planet. How much does a cubic kilometer weigh? About 1,000 million tons. Depending on its purity and temperature, on the U.S. short scale, this is 1.1023 billion tons. 1 cubic meter of water contains 1,000 liters and weighs about 1,000 kilograms. There are 1 million cubic meters, 1,000 times 1,000 times 1,000 in a cubic kilometer. Considering there is this much water in the oceans and the weight of the vast amount of water displaced by the daily tides and all the speeds involved, when applying the laws of physics and recognizing that this is achieved with the 1.62 meters per second squared gravitational pull of the moon, how do you not find it absolutely amazing to see what we do in the skies?